This is Cisco Training with Darrell, episode 11. Today we're going to migrate from RIP version 1 to Igrp using route redistribution. I have a few administrative items to talk about first. I moved the iTunes feed from .Mac to SwitchPod a couple weeks ago because I hit some bandwidth limitations. So that's hopefully hopefully the migration was seamless and all of you are downloading episodes fine. If you have any problems, send me email at ciscotraining@mac.com. My website remains on .Mac, web.mac.com/DarrellRoot. I'm also starting to add some additional information on the website, including static pictures of the diagrams, and Chris Strass contributed a network diagram with configurations for 2600 series routers. It's on the RIP version 1 webpage. So for those of you running 2600s or routers more modern than that, your serial interface configuration is completely different than the serial interface configuration on the 2500s, because on the 2600s you have integrated CSU DSUs, it supports time slicing, so the config is different. Chris has a good configuration example for you. Okay, let's get into today's session. Here is the map for today. I've moved the IP address ranges up into the 192.168 address space. That's a class C because the first bit is 1, the second bit is 1, the third bit is 0. It's still it's another block of RFC 1918 address space. That's the request for comment. RFC is request for comments. 1918 or 1918 is the RFC that specifies private address space. So address space that you can use in a lab. I have 3 routers connected /24s. The reason I moved up here is that way I can control which routing protocol I'm running on which interface, because the natural net mask is a /24 up in class C land. And let's go ahead and look at our router. Show run. Here's a standard. Here's the configuration I'm starting with. Interface loopback 0, IP address, interface serial 0 and serial 1. I configured the clock rate on my DCE interface. This no fair queuing command was default. Router RIP version 1. Then I have to, in this case, I have to specify 3 network statements because the natural class full mask is a /24. Now, many people remember the configs from the previous episode, 172.16.0.0. So when they're using 192 address space, they use 192.168.0.0. But that would be an error because that would only turn on RIP for IP addresses which start with 192.168.0 and then something. And so that would not turn on RIP on any of these interfaces. That is it for the config. Let's test it. Ping 192.168.3.1. That's my left router. Ping 192.168.5.1. That's my right router. You notice I renamed my routers today. I've still got a top router. I have a left router and a right router. Now on my desk, my routers are stacked on top of each other, but I moved the left router, the top one's on the top. I moved the left router a couple inches to the left in the stack. I moved the right router a couple inches to the right in the stack. That way it's easy for me to remember, and it's easy for you to see how they're connected on the diagram. It's more intuitive. Okay, let's start our migration to Igrp. So conf t router Igrp. I need to identify my autonomous system, router Igrp 65000, router Igrp 65000. And then network 192.168.1.0, router RIP, no network 192.168.1.0. Now if I do show IP proto, show IP proto is a command which shows you the routing protocols running on the router. So you can see I've got router RIP, and on each of my interfaces I'm sending and receiving version 1. But now I'm only doing it on serial 0 and serial 1. I'm not running router RIP on loopback 0. And then IGRP, and I'm routing for networks 192.168.1.0. So let's go to the left router and see if I can ping the loopback interface. Okay, 192.168.1.1. I can ping it. Let's do a show IP route. Now this is interesting. I can ping it right now, but my network is still broken. And the reason my network is still broken is because I have this 192.168.1.0/24 is possibly down. Why is it possibly down? Let's do a show IP RIP database. Show RIP database. Show ver. This router doesn't let me look at the RIP database. That's unfortunate. It's possibly down. And the reason it's possibly down is, well, let's look debug RIP. Debug IP RIP. Let's look at the let's look at what advertisements I receive on my serial 1 interface. And we might have to wait up to 30 seconds because RIP sends advertisements every 30 seconds. Dun 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 dun. Ah, here we go. Did I receive the one I wanted? There's serial 0. There's serial 1. No debug all. So I received this update on serial 1, but it did not have the 192.168.1.0/24 subnet in it. And the reason is because I turned that subnet off in RIP, and I have it in IGRP. But this router's not running IGRP, and my top router is not sending IGRP advertisements out that's interfaced this way. So show IP proto. Actually, show IP route. Let's look at what my route thinks my route. So the route is possibly down. And in a minute or two after the hold time, what is our hold time? Our hold time is 180 seconds. And it's invalid after 180 seconds. So if we wait 3 minutes, then we're going to be able to see that the route is no longer valid. Ping 192.168.1.0. I can still ping it at this point. I'm not going to wait for the whole 3 minutes here, but I've got a problem. I've broken my network. I turned off RIP on an interface. I turned IGRP on the interface on this top router. And now that subnet is not being advertised anymore. And so as soon as my timers expire, then this network's going to become unavailable. And that could be bad. I could have a critical web server on that network, and as soon as it becomes unavailable, then people will be paged, and management will want to know what happened. So we've got to fix it. We've started our migration, but we've already made a mistake. And there it is. That route is now gone in our route table. So now if I ping, so the 3 minutes have passed, and now I can no longer ping 192.168.1.1. Okay, we have a network outage in progress. 2 ways to fix it. One way to fix it is to back out of our change. The other way to fix it is to continue our change. Let's continue our change since we're learning about redistribution, and that's the problem. We're not redistributing. We're doing ships in the night routing. We have IGRP enabled up here. We need to get that route into RIP, and we need to get our RIP routes into IGRP. So let's start conf t router RIP redistribute IGRP 65000. So you need to redistribute from so I'm in the RIP protocol. I'm redistributing from IGRP autonomous system number 65,000, and I can do it with a metric or a route map. We're not going to talk about route maps today. Why do I have to specify a metric? We know what the IGRP metric is. Well, the problem is when you metrics in different routing protocols are not comparable. The metric in RIP is hop count. The metric in IGRP is a number based on the bandwidth and the delay. So since it can't compare the metrics, I have to specify the metric, and then the default metric, I can give it a number from 0 to 16. 16 is infinite. This is going into the metric in RIP, so it's hop counts. So usually when you're redistributing, you want to pick a metric that is higher than the native RIP metric. So let's try 3, because our network is less than 3 hops to get anywhere. End. Debug, show IP RIP database. So now on this router is running a more recent iOS version. It's running a 12.2t version. And we can see that in the RIP database, 192.168.1.0/24 is redistributed. So, debug IP RIP. Let's see what we're advertising out our 2 RIP interfaces. No debug all. And you can see, even though I'm directly connected to 192.168.1.0, when I advertise the RIP, it has a metric of 3, because when I redistributed, I set a metric of 3. Now there was one other command in the redistribute IGRP, in the redistribute command. Well, let's not worry about that transparent option now. We've started our migration. We now have 2 routing protocols, RIP and IGRP. We're redistributing from IGRP into RIP, so we've restored our network connectivity. In fact, let's go ahead and test that. Going back to the left router here. And so I can show IP route for a specific route. In fact, I don't think I've shown you this command before. You can do show IP route and hit return, but you can do show IP route and type in an IP address, and it shows you the specific entry for that route with more information. And it shows you it learned it via RIP. Its distance is 120, which is the administrative distance of RIP. It's a metric of 3, and last update it received was on interface serial 1 2 seconds ago. Okay, let's continue our migration. Let's take another subnet and get it into IGRP. So, going on the top router, conf t router RIP no network 192.168. Actually, this is bad practice here. Usually you want to put it in the new routing protocol before eliminating it from the old routing protocol. Router IGRP 192.168.2. Router IGRP, I'm sorry. Router IGRP 65,000. Get in router IGRP stanza mode. Now network 192.168.2.0. Now router RIP no network 192.168.2.0. End. So, and since this is the 192.168.2.0 subnet, let's also turn on IGRP on the left router. Conf t router IGRP 65,000, network 192.168.2.0, router RIP, no network 192.168.2.0. 0n. Show IP route. Now our routing table is more interesting. We have an IGRP route from our IGRP neighbor. We have RIP routes from our RIP neighbor. Let's go to the right router, which is still a purely RIP router. Show IP route. Now it only has RIP routes. It has the 192.168.1.0/24, which is, it has it with a metric of 3. And it has 192.168.2.0 via RIP with a metric of 1 via 192.168.4.1. And we turned off that subnet in RIP. So it's getting this subnet 192.168. We're on the left or the right router. We're getting the subnet 192.168.2.0/24 from the left router via RIP. Let's look at that route advertisement in more detail. Show IP route 192.168.2.0. And you can see it got the route 1 minute and 51 seconds ago. The last update was 1 minute and 51 seconds ago on that router. So what's going to happen when that timer runs out? And I wish I could show the IGRP database. Show IP route 192.168.2.0. That route should be redistributed via IGRP. What's interesting is, actually, I'm sorry, we're only getting that via RIP. We're not running IGRP here. We're not getting any IGRP routes. So we've broken, and in the top router, we should be redistributing that into RIP. So it's 2 minutes and 53 seconds ago. We're almost at the 3-minute mark. And now we're still getting it from the left router. Why is the left router advertising it? Actually, no, it's not advertising it. We're just not at the timer yet. So let me actually stay on the right router. Show IP route. And now it says it is possibly down. It's routing via the router on the left. So why is the router on the top not advertising it? So here we are on the top router. Show run. And we're redistributing IGRP. That router should be in IGRP. So debug IP RIP. Show IP RIP database. Okay, so we sent an update via serial 1, and it included 192.168.2.0 metric 2. And which is interesting. So no debug all. Show IP RIP database. And 192.168.2.0 is directly connected in RIP. Show run. I think we found what I would call a bug here, because that network is no longer in. That we executed a no network statement, so that network should no longer be advertised via RIP natively. clear IP route. Let's do a clear IP route. Clear IP route star. Clear IP route star. This is an unusual command. It clears all the routes in the routing table. Show IP route. That shows us it's directly connected. Show IP RIP database. And now you can see 192.168.2.0/24 is redistributive. So sometimes when you're executing routing protocol changes, where you're actually, turning off network statements, sometimes the router doesn't catch that. Now that's a bug. The router should update its internal tables appropriately when you do that, but in this case it didn't. And so we had to clear IP route star in order to get the router to recalculate all of its routes and correctly advertise it. So now let's do a debug IP RIP and make sure that our advertisement is going out with the metric of 3. And there it is. Now it's going out with the metric of 3. No debug all. Now let's go back to the right router and see what the right router thinks of its routing table. And now it shows that it is receiving 192.168.2.0/24 via the top router. Okay, so let's go ahead. At this point, let's regroup. At this point, we have Igrp running on the left router and the top router. We have 2 subnets in Igrp. The 192.168.1.0/24, 192.168.2.0/24. Our other 1, 2, 3, 4 subnets are in RIP. We are redistributing only on the top router. Let's look at our show. And the thing is, on our redistribution, we're redistributing from RIP. We're redistributing from Igrp into RIP only. We're not redistributing from RIP into Igrp. So at this point, we have 2 routers that are RIP and Igrp, and 1 router that is RIP only. Now, to see what sort of problems we have, let's make the left router a pure Igrp router. So let's go on the left router. Conf T router Igrp 65000, network 192.168.3.0, network 192.168.4.0, no, and then exit, no router RIP. Show IP proto. And now I have only 1 routing protocol. It is Igrp. Do a show IP route. And you know something? I'm missing a lot of routes. There are 6 subnets in my network, but I'm only seeing 4 of them. I see the 3 directly connected, and I'm learning 1 route via Igrp from the top router, which is the loopback interface of the top router. The routes from the pure RIP router, the routes from the RIP domain, I'm not learning. And the reason is because I'm in a pure Igrp router, and there is no redistribution from RIP into Igrp in the top router. Let's go ahead and look at the top router. So here, router RIP, I am redistributing Igrp into RIP with a metric of 3. But I am not redistributing anything into Igrp. So let's redistribute into Igrp. Conf T, router Igrp 65000, redistribute RIP metric. Now the metric here is complicated because a Igrp metric has 5 metric components: bandwidth and delay and several others. But bandwidth and delay are the only ones that are actually used by default in the routing process. So let's set a bandwidth. Usually you want to set a small bandwidth, Redistribute RIP metric, we'll go with a bandwidth of 64 kilobits. Hit question mark again. What's the delay in 10 microsecond units? I'll go with 1,000 microseconds. I'm just picking large numbers. Reliability, we're 250. So reliability, this is not used. I just make it all reliable by typing in 25. Bandwidth loading, I'll set 1, which is not loaded at all. Again, this is not used. MTU, usually you want to use an MTU of 1500 because that's the MTU of Ethernet. What is an MTU, you say? It's the medium transmission unit, or media transmission unit. It is the number of octets that you can send in one frame across the wire. An octet is just a fancy word for byte, except octet is 8 bits. Now, a byte, as you know, is usually 8 bits. Occasionally, some operating systems have bytes that are different sizes, so we measure frame size in octets, because it's got to be exactly 8 bits. Okay. So now we're redistributing Igrp into RIP. I'm sorry, we're redistributing RIP into Igrp. So now we are doing mutual redistribution. Let's go back to the left router, which is our pure Igrp router. Show IP route. And I'm not seeing it yet. Let's go back to the top router. Show IP route. Show IP proto. In IP proto, it says I'm redistributing RIP into here. Debug. Last update was 41 seconds ago. Debug IP Igrp. Debug IP Igrp events. Debug IP Igrp transactions. Okay. So I've received an update on serial 0 I received 2 networks. I'm looking for an update that I sent out. And that might take up to 90 seconds to occur. So let's talk about the big picture here. We've got a triangle. In most triangles, if you lose any leg of the triangle, you can route over the other 2 and you're fine. But our left router and our right router at the bottom are not talking to each other in terms of a routing protocol, because the left router is running Igrp and the right router is talking RIP. The top router is talking Igrp out the left interface and RIP out the right interface, and it is redistributing between both routing protocols. Let's go ahead and look at the left router. Maybe it just took a minute or so. There we are. Okay, so now I've got all 6 routes on my left router, and here you can see that the 6.0 and the 5.0 are the ones that are redistributed. And you see this one it has an administrative distance of 100 since this is Igrp. So we are halfway done with our migration. We now have Igrp running on the left routers. We have RIP running on the right. On the right router. The top is redistributing. Let's get Igrp working on this link here. Now the left router is already configured with Igrp, so let's go ahead and configure it Igrp on the right router. One of their comments on this route table here, all 3 routes have an administrative distance of 100 because the route is redistributed, but it is, Igrp has an administrative distance of 100. There's nothing in the route advertisement which says that the route is redistributed, or at least there's some routing protocols, some more advanced routing protocols have a different administrative distance for what are called the external routes that are redistributed. Igrp does not appear to use that feature. So right router, conf t, router IGRP 65000, network 192.168.4.0, node, or router RIP, no network 192.168.4.0, and show IP route. Now all of my routes are either connected or IGRP. I don't have any RIP routes. Why not? The reason is because when I'm receiving these routes via RIP and IGRP, because I'm still talking RIP to the top router, but I believe IGRP more because IGRP has the lower administrative distance. At this point, my migration is basically done, because on the top router, turn off debug, no debug all. On the top router, show IP route. On the top router, I'm receiving almost all of my, I have 3 connected routes, I have 2 IGRP routes, and 1 RIP route. So the reason this is a RIP route is because the right router still has RIP configured on this loopback interface, but not IGRP. So let's go ahead and go to the right router and finish our migration. Conf T, router IGRP 65000. Now what I need to do is enable IGRP, network 192.168.5.0, network 192.168.6.0, exit, no router RIP. So I've turned on IGRP in all of my interfaces here. Let's go back to the top router, show IP route. 192.168.5.0 is still RIP. So I've enabled that in IGRP on the right router, but I haven't received it yet. I haven't received the route advertisement yet. And I believe that if I just wait some time, I will receive the advertisement.